looking at this interview slash Leetcode problem. So we are going to create this function island perimeter that is going to take a grid as a parameter and is going to return the perimeter of the island described in this grid. This is the island, and then inside this island 0 represents water. For each cell 0 represents water, and for each cell 1 represents land. And then each cell is a square, which means it has 4 sides and the length of 1. And then the cells are connected horizontally and vertically and horizontally. And then grid is rectangular and etc. So what's happening here is that if we look at this grid, you can see that the perimeter of this grid, by just looking at it, we should have, since each line cell which is the element of 1 has 4 sides, and we have about 5 of it, so it's 4 times 5, which is like 20 perimeters. The perimeter is 20. The perimeter is 20. I'll use this as the representation of this grid just to keep the line in view. So what's happening here is, for each line cell, this line is 1, this one is 1, this one is 1, this one is 1, which is 4. And then for the next line cell, 1, 2, 3, 4. For the next line cell, 1, 2, 3, 4, just like that. So to be able to get the perimeter, what we are going to do is we are going to loop through this grid, and then we are going to start removing any line cells that have another line cell on top of it, or below it, or at the left of it, or at the right of it. We are going to see, for instance, here now we see that we have a line cell here and here, that is, one is on top of the other. So for each of them, we see that we have the left side of this one is contributing to the perimeter, the up side, and then the right side is contributing, but the below part that connects to this one is not contributing because it's connected. We are going to subtract it from this perimeter, subtract 1, and then we are going to check this one. We see that it has 4 sides and 1 is connected to up here, which means it's not contributing anything to this perimeter. We subtract another 1, and we check under it, and we see that it's connected to another land cell, and which means it's not contributing to this perimeter. We subtract another 1. Just like that, we move to the next one. We check up, the upper side of it is connected to another land cell, which means it's not contributing. We subtract 1 from it, and then we check the right side, and we see that it's connected, which means it's not contributing. For this one, we subtract 1 from it. Now we move to the next one. We check for this one, the left side is not contributing because it's connected. We subtract 1, and then we see that the right side is also not contributing because it's connected to this land cell. Then we subtract 1, and then we check this one, and we see that it's only connected to the left side, which means the left side is not contributing to this perimeter, and then we subtract 1. So when we subtract 1, 2, 3, 4, 5, 6, 7, 8 from 20, we are going to be left with 12, which means the perimeter of this island in the grid will be 12, which is the expected output. So now let's put this in code. So here I've declared the perimeter and set it to 0. So what we are going to do is we know that if we look at this grid right here, we'll see that the perimeter is 20. That is, if we calculate all the four sides of each land cell, multiply it by the number of the land cell, that's 5 times 20. So for us to do this, we look through the grid. We say for I in range, and then going to be the length of the grid, and then for each one we look through, we want to access all the elements of the inner list. So we are going to say for j in range, and we are going to is going to be the number of the grid. That is, here we are looking through the rows, row 1, row 2, row 3, and then the inner loop is going through the columns. So each time we go through this, what we are going to do is we are going to say to be able to access all the land cells, we are going to check every index. We are going to say if grid I and grid j. So this is how we'll be able to access the current index. So we check if the current index has the element 1. If it has an element 1, we are going to increment perimeter by 4, because remember that each land cell has 4 sides. So for each time we find an element 1 in the current index, we increment perimeter by 1. So by the time we loop all through this grid, we are going to get 4 times 5, which is 20. So we are going to get perimeter 20. So the next thing we are going to do is like we said before, we are going to now find the land cell that is connected to another land cell below or by the side. If there is below, we remove the line that's connecting the two. We subtract 1 from perimeter and we check the next one. If there's 1 above it, we remove 1, subtract it from perimeter, and if there's 1 below it, remove 1 and subtract it from perimeter. So we are going to check every land cell here to see if there's a land cell above each of them, and we are not going to start at this index 0 for I, because we know that this is an island and is surrounded by water. So index 0 for I shouldn't have any land cell above it. And then so now we are going to check if there's a land cell above the current land cell, that is the current index. And then if there is one, we are going to adjust the perimeter accordingly by removing the shared side between the land. So we are going to say if I is greater than 0, so that we don't access this first one, we have to start from here to be able to check for land cell above it, because there's none above the index 0. So and grid I minus 1, this is the way to access the cell above it. If the cell above it has an element that is equal to 1, we are going to decrement the perimeter by 1, just like we said before. If this element has 1 above it, like assuming we are at this element and it has a line cell above it, it means that the connection, the line that is holding the both of them is not contributing to anything. So we have to subtract one from the perimeter. That's exactly what we are doing here. And then excuse me. So we are going to also check if there's a line cell below the current cell block and adjust the perimeter. So we are going to say if I is less than the length of the grid minus 1, because we know that the length is going to be, the length of the grid is going to be 1 2 3 4 5, but since it's going by index we have to take one out of it. And then and grid I plus 1, know that we subtracted 1 from here, because assuming we are at this place which is index 1 for I, and we want to access this cell block above I, we have to subtract 1 from index 1, which is 0, which will bring us back here. So in that same manner, if you want to check the cell below this index, if we are at 1, we add 1 to it, which is 2, which is going to bring us here. So J, so if this land cell is 1, if we find a land cell below this, below the current index, we are going to remove 1 from the perimeter, which means that that this land cell below the current land cell and then the side is contributing nothing to the perimeter, so 1 is removed from the perimeter. And then similarly we are going to check for land cell beside each of every line cell. We are going to check for beside, because here we succeeded in checking for above and below, so we are going to still check for the left side and the right side. So in the same manner we are going to say if J is greater than 0, because since we are checking this way horizontally by the column, we do not want to start from here, which is index 0 of J. So we want to start from index 1, because index 0 has no cell at the left side. So since we are checking for the left side, we are going to start at index 1, which is index greater than 0. And then we say and grid I. In the same manner we assessed the cell above by subtracting 1, we are going to access the cell by the left by subtracting 1 from J. So we say J minus 1. And then if the element there is 1, we are going to take away 1 from the perimeter, meaning that that side that is shared between the two is contributing nothing. So again we are going to check if J is less than the length of the grid. So and then we check if, to access the element at the right side, we are going to, just like we did here, we added 1 to check the one below. So to check the one at the right side, we are going to add 1 to the J, which is going to move it to the right side. So if the element there is 1, it means that the line between the two is contributing nothing, so we are going to subtract 1 from the perimeter likewise. Then after taking away, subtracting or removing the non-contributing size of each land cells, we are going to return the perimeter. So we return perimeter. So if we should run this, okay, hold up. Okay, this should be length in this. Okay. Okay, so the thing is, I was I was doing this outside of this check, so I have to move all this inside of the check.
Show that for every land cell found must have been incremented by 4 for the perimeter.
So now that we've done this, if I should run this again, let me take out the print statement. If I should run this again, now we see that we get the right thing.